Pure Maths 1, October, November 2024, Variant 2. So let's begin with question number 1. For question number 1, it is given a trigonometry function. Okay, so it's given a trigonometry function, a sine graph. Okay, there's given a sine graph. And they ask you to find the amplitude A, the period B, and C. Okay, so since it's a basic sine graph, we're going to just draw a basic sine graph. So usually it's this. So let's say y equivalent to a sine x. So this distance is known as a. The distance from the midpoint to the highest point is your a. So if you see, it's from 3 to 7. Therefore, my a is equivalent to 4. Okay, and then b. So b will be the period. So if you notice here, so 2 pi divided with b is equivalent to pi, because the period here, you see, for it to make one complete cycle, okay, for it to make one complete cycle, the period here is pi. Okay, so it's going to be b equivalent to 2. And for c, it's supposed to start at 0, so means this one must be at 0, but it moved 3 units up, means it's translated 3 units on a vertical direction. So your c will be 3, because the c here is actually the translation in y direction. Okay, how many units go up in y direction. Okay, so this will be your a, b, and c. 1b. For this ABC, determine the number of solution in the interval of 0 to 2 pi for each case of the equation. Okay, so here is given a sine bx plus c equal to 7 minus 7 minus x. So just now we can see this one is equal to y. So we just make it this equation as a y. So y equivalent to 7 minus x. So it is a linear graph. So it's a linear graph. So when x equal to 0, y equal to 7. So I just erase here. So y equal to 7 minus x. So we try to sketch this straight line. So when y equal to x equal to 0, y equal to 7 is here. And let's say when x equal to pi, x equal to 0, y equal to 7. When x equal to pi and y will be 3.858. So it's approximately 3.58. So approximately here, let's say. So we just draw a straight line from connecting these 2 points. Okay, so this will be y equal to 7 minus x. Therefore, the number of solution will be 1, 2, 3, 4, and 5. So there are 5 solutions. So there will be 5 solution. Okay. Similarly, for this, we can draw this one, we can make it as a y. So y equal to 2 pi x minus 1. So we try to sketch this graph. So y equal to 2 pi x minus 1. So maybe we put x equivalent to 1, and then your y equivalent to 0. So x equal to 1 will be approximately, so this is 1.5. Wait. So approximately here, okay, and maybe we put x equivalent to, or maybe we can put y equivalent to 2 pi. So we can find the x, so x will be 2, okay. So when y equal to 2 pi, approximately here, and y equal to 2 will be approximately, so will be approximately here. 2 will be here somewhere. So we just randomly draw me. So just draw a straight line. Okay, so there is only one intersection. Okay, there's only one intersection. Therefore, there will be only one solution. One solution. Okay. And then for question number 2, the first term of an arithmetic progression is negative 20 and the common difference is 5. So here you can write a equal to negative 20 and your d equal to 5. Okay, so find the sum of the first 20 terms. So I just picked the formula from the formula booklet. So you can refer to your formula booklet. You will have this formula. Okay, therefore we just utilize the formula here. So it's going to be S20 is equivalent to n1 over 2n bracket 2a plus n minus 1 d. Okay, so you just press this in your calculator. So you'll get 550. Okay, and for B, it's given that the sum of first two k terms is 10 times of the sum of first k terms. So it means your S2k, so S2k is equal to 10 times of SK. Okay, so we apply the formula n over 2, so 2k over 2, 2a plus n minus 1d equivalent to 10 n over 2, 2a plus n minus 1 d. Okay, so it's going to be, I can cancel my k and k here. Okay, then I can factorize the 5 out, so it will be 5 bracket 2 negative 4 plus 2k minus 1 equivalent to 5. I cancel this. So 5 2a plus 5k minus 5. Okay, so I can cancel my 5. It's very easy for me. Therefore, negative 8 plus 2k minus 1 is equivalent to negative 40 plus 5k minus 5. Sorry, it should be 5. 5. Okay, so you rearrange, bring k to one side and all the numbers to another side, integers. So it will be 3k is equivalent to 36. So k equal to 12. Okay, so just take note here. your k 2k and the k will be your n because it's something like this Sn. So for this case, your n equal to 2k, and for this case, your n equal to k. Just ignore that. Okay. Question number 3. The equation of a curve y equal to 2x squared minus 3. 2 points A and B with x coordinate 2 and 2 plus h respectively lie on the curve. Find and simplify an expression a gradient of chord A in term of h. So here, since they say a chord, something like this. Let's say this is my point A, this is my point B. So it's just a straight line here. Okay. So to find the gradient of this, so x1, y1, x2, y2. Okay. So you want to find the gradient, you need your x coordinate, y coordinate with x coordinate, y coordinate, so that we can sub in and get the thing. So when x equal to 2, my y will be 2 bracket 2 square minus 3. Therefore, my y is equivalent to 5. Similarly, when x equal to 2 plus h, my y will be 2, 2 plus h square minus 3. So my y will be 2 h square plus 4h plus 4 minus 3. So you simplify this, you will get 2h square plus 8h plus 5. Okay, therefore the gradient of chord AB will be y1 minus y2, so 2h square plus 8h plus 5 minus 5, y1 minus y2 over x1 minus x2, so which means 2 plus h minus 2. So will be 2h square plus 8h over h. Therefore, MAB, you can cancel off the h, you'll get 2h plus 8. Okay, so just can cancel off. I just simplify this. So h 2h plus 8 over h, so you can cancel like this. Okay, now B, explain how the gradient of curve at point A can be deduced from the answer part A and state the value. Okay, if you really look into this, let's say there's a curve and you want to find the A. You want to find the gradient A. So what usually we do, we will use the tangent, gradient of tangent. So means the gradient at point A is equivalent to the gradient of the tangent at point A, right? Okay, how we will do this? We will do by using differentiation. So dy over dx, and then we substitute our x value, right? Okay, for this case, let's say B is here. Okay, so how this um, can be lead to find the gradient of A? So that's the question. Okay, so by using the first principle of derivative, okay, first principle of derivative, where your dy over dx is equivalent to limit del y over del x, where the del x stands to 0. Okay, this is the first principle of derivative, if you still remember. Okay, we often use the h also, where my del x is small change in x. Means when your change in x approximately 0, then we can find our dy dx. So similarly here, the gradient of MAB is represent my dy dx, correct? The gradient. Therefore, in order to find this, my h is actually a small change in my x. Why? Because if you notice here, they said 2 become 2 plus h. Okay, means when h approximately 0 or tends to 0, therefore my dy over dx will be 2 multiplied with 0 plus 8 equivalent to 8. Okay, so you must use the first principle of derivative and you must know this. Okay, where del x is a change in x, so you can see here is from change from 2 into 2 plus h, so the h denoted as a small change. Okay, question number 4. Find the independent term of x in the expansion of the following. So x plus 3 over x square power of 6. So here I quote the formula from your formula booklet. This. Okay, so it's one I took from the formula booklet. So you can refer to that. So this is a binomial expansion formula. So when they say the independent term of x, which denotes that the coefficient of x power of 0. Okay, the x power of 0. Okay, so here we just write the thing, so it's going to be x plus 3 over x square power of 6. If I just take the general formula, general way, so it's going to be 6cr bracket, my a here is x, so x 6 minus r bracket, b is 3 over x square, 3 over x square power of r. Okay, you just ignore this. So since they said it must be x power of 0, so I just find my r first, where here is going to be x power of 6 minus r multiply 1 over x to r equivalent to x power of 0. Therefore, if I make it simpler, so x power of 6 minus r minus 2r equal to x power of 0. So, oops, sorry. So 6 minus 3r equal to 0. So r will be 2. Okay. So means your r equal to 2. So we're going to find out when 6c2. So the independent term will be 6c2 x power of 4 3 over x square power of 2. Okay. So it will be 15 multiply with x power of 4 multiply with 9 over x power of 4. So x4 will cancel each other, so this will be 1 3 5. Okay, so therefore the independent term of x is 135. Okay, and for b, the question asks you to find the independent term of this function. Okay, so if I do this, I'll supposed to get x power of 6 all the way until 1 over x power of 12. Okay, so I'll get all these things. So if I want to get an independent term, so 4 power of x power of 3, 4 power of x power of 3 multiply a over x power of 3. So this and this will cancel, so it's 4a. Right, so I will get an independent term in this term. Okay, and then for the second independent term, it will be negative 5 multiplied with the previous one, 135. Okay, that one we can do later. So we find the a first. Okay, so in order to find the a, so we use a similar idea with this, but here instead of 0, it's going to be negative 3 because I need this. Okay, because I need x power of negative x power of 3 here. So it's going to be x 6 minus 3 r equal to x power of negative 3. So 6 minus 3 r is equal to negative 3. So r will be 99033. Okay, so we find the a first. So it's going to be 6c3 x power of 3 3 over x square power of 3. So it will be 540 over x power of 3. Therefore, the independent term will be 4x cubed multiplied with 540 over x cubed plus negative 5 multiplied with 135. Okay, so x cube will cancel, therefore it will be 1485. Okay, let's continue with the question number 5. The function is given as 2x plus 1 over x minus 1. State the value of f negative 1. Okay, so for this we can directly substitute in. So it's going to be f negative 1 will be 2 bracket negative 1 plus 1 over 2 bracket negative 1 minus 1, which is going to be 1 over 3. That's it. It's quite straightforward. Okay, in the diagram shows the graph y equal to fx. So this is y equal to fx. Sketch the graph of y inverse on the diagram. Show any relevant mirror line. So when I said any relevant mirror line, it indicates the y equal to x line. Okay, you have to show the y equal to x. So before that, we need to know whether there is any asymptotes or not. Okay, so normally for this, there will be asymptote on the y because it's 1 over x. So let's say for this, I rewrite. Okay, my fx equal to 2x plus 1 over 2x minus 1, correct? Okay, so what I'm going to do here is I'm going to break this constant into minus 1. So 2x minus 1 plus 2 over 2x minus 1. Okay, so it's going to be 2x minus 1 over 2x minus 1 plus 2 over 2x minus 1, which is going to be 1 plus 2 over 2x minus 1. Okay, why I do like this? So from here, if it's a reciprocal graph, so basic reciprocal, if it's a basic reciprocal, the x equal to 0 and y equal to 0 will be the asymptotes, correct? So when it has something like this, it shows that for this your x equal to 1 over 2. So I just draw, I just use another color, easier. So my x equal to 1 over 2 and y equal to 1 is the asymptotes, means the graph cannot touch these two lines or intersect these two lines. Okay, this is the idea. Is that clear? So why I put here my negative 1 plus 2, because I want to break something similar here. So in denominator I got 2x minus 1, so I want to have something like similar with here, 2x minus 1. And but I cannot change the original question. So here is plus 1. So negative 1 plus 2 is plus 1. So I got something like this. And then I split them. So this will be my asymptotes. Okay. So now when I want to draw the inverse graph, my domain will become range, my range will become domain. So I just change my ink color, so I go to blue color. So just now, if you notice, it will be y equivalent to, sorry, x equal to 1 over 2, right? So now it become y equal to 1 over 2. Okay, so y equal to 1 over 2 will become the um, isotopes. So maybe I just draw a bit higher so they're easy for me to draw. Okay, so y equal to 1 over 2 will be the isotopes, and similarly x equal to 1 will be the isotopes. Okay, so it will be here, it intersect at somewhere this point and here, so it will be intersection points here and here. So it should be something like this. Okay, so I can erase this because this is not necessary. So your graph will look something like this. Okay, so this will be y equal to f inverse x, and it's going to be something like this. It's okay. So y equal to x. Okay, so this is your graph, and then they ask you to find the expression for this. So we let my fx equal to y, which means 2x plus 1 over 2x minus 1 equal to y. So 2x plus 1 equal to 2xy minus y. So it's going to be 2xy minus 2x equal to 1 plus y. So your x will be 1 plus y over 2y minus 2. Therefore, your f inverse x will be 1 plus x over 2x minus 2, where your x cannot equal to 1. Okay, so the domain, this is not necessary, sorry, this is not necessary. So they already asked you the domain. So the domain just now, if you realize, it must be less than 1. Okay, you can see just now I draw the isotopes, right? So this is my isotopes just now. Okay, x equal to 1. So if you notice, the domain is smaller than this. So domain of f inverse x will be x smaller than 1. Okay, and then for this question b, the function is defined by gx equal to 3x plus 2, where fx equal to this. Okay, so for g f1 over 4, we don't make things complicated, so we solve for f1 over 4. So f1 over 4 is going to be 2 bracket 1 over 4 plus 1 over 2 1 over 4 minus 1. So you will get negative 3. Therefore, g f negative, sorry, 1 over 4 is actually g negative 3. Therefore, g negative 3 is equivalent to 3 negative 3 plus 2, which is negative 7. Okay, so now we can say it, fx equal to g f 1 over 4 is actually equivalent to negative 7, fx equal to negative 7. So we solve 2x plus 1 over 2x minus 1 equal to negative 7. So 2x plus 1 equal to negative 14x plus 7. So it's going to be 16x is equivalent to 6. So x will be 3 over 8. Okay. We go to question number 6. So for question number 6 is given this, and the question mentioned that the perimeter of the plate is 14 and the area of the plate is 10. And I already plugged the formulas from your formula sheet. This is your formulas from your formula sheet. So you can utilize this from your formula sheet. You can refer to this. Okay. So since they said the perimeter of the plate is 14. So I'm going to add up OA plus AB plus CB plus D plus DE plus EF plus FO. So this is the perimeter, right? So it's going to be R plus, for AB it will be R theta. So R theta CBC will be R plus CD will be R theta, which is radius here is 2R and theta is 2 theta, plus DE, which is R plus R theta plus R, equivalent to perimeter is 14. Okay, so if you simplify this, so you'll get 1, 2, 3, 4R plus 4 plus 6. So 6R theta equal to 14. So you can simplify this, 2R plus 3R theta equal to 7. Okay, this is the first equation. And for second equation, it's going to be area. So area of plate is 10. So here I got 2 small. So it's going to be, for the small sector, 1 over 2 R square theta. And since I got 2, I just multiply this with 2 plus 1 over 2 R square theta is equivalent to 10. Okay, so it will be R square theta plus 4R square theta equal to 10. So 5R square theta equal to 10. Therefore, R theta will be 2 over R. Okay, I just divide with 5R so that I can have a 5R theta. So this R theta I can sub indirectly, so it is easy for me. So 2R plus 3R theta will be 2 over R, equivalent to 7. So multiply everything with multiply everything with R. So get 2R square plus 6 equal to 7R. So 2R square minus 7R plus 6 equal to 0. So we factorize this. So we'll get, oh, I just write here. So will be R minus 2, 2R minus 3 equal to 0. So R equal to 2, R equal to 3 over 2. And if you notice here, the question mentioned your R is more than 3 over 2. Therefore, your R equal to 2. Okay. And from here, R theta equal to 2 over R. So R is 2, theta equal to 2 over R. So theta equal to 1 over 2. Okay. So that's all from me. Thank you.